Okay guys, we're going to talk about number patterns today. So in number patterns, basically what you're going to get almost always is you have to find an equation. Find an equation. Okay, so every number pattern that you are going to recognize, there's going to be a different set of equations that you can choose from to use in order to answer those questions. So again, what I'll do is I'll give you a summary of everything, and then we're going to look at the assignment, was sequences and series assignments. Okay, so number patterns, we get sequences and series. Sequence means they just a sequence of numbers separated by semicolons, and then series, then the terms of the sequence are added together. So I would have a sequence would be term 1, term 2, term 3, etc., while a series would be term 1 plus term 2 plus term 3. So it's the same terms, they're also called terms, but if it's a series, we're adding those terms. So if they ask you to write the first 3 terms of the series, you write this. If they ask the next 3 terms of the sequence, then you write it like that. If you swap them around, if you put commas in between and they ask for a series, it's wrong. Make sense? So that's very important to just understand the difference there. Okay, and now let's look at the different sequences and series. So we get, should have added myself a little bit more space on this side. Let's do this. Okay, so for example, we start with the arithmetic. Okay, so arithmetic. What do you guys know about the arithmetic? How will I recognize an arithmetic?
Common difference.
Common difference. Okay, now that gives us our first equation. Common difference means if I take term 2 and I subtract term 1, that's what we call the difference between the terms. I will get the same answer as taking term 3 divided by term 2. Okay? Sorry? Did I make a mistake? Oh, sorry. Okay. So term 2 minus term 1 is equal to term 3 minus term 2. Thank you. I want to show you something else as well. If I solve for term 2, okay, term 2, notice if I add term 2 on both sides, then I get rid of this one. You see that? And here I now have 2. Term 2's is equal to term 1 plus term 3. Are you with me so far? Do you see how I get it? Is that too light? Is that okay? Should I make my size a little bit bigger? Okay, let's see, like that. Now if I want to get term 2, I can just divide by 2 on both sides, and I get term 2 is equal to term 1 plus term 3 divided by 2. What does this tell you? This is always true in an arithmetic sequence, I mean. How would you interpret term 2? Term 1 plus term 3 divided by 2. What do we call this expression? Who knows? Come on, guys.
Isn't it the average?
It's the average between the two. You see? That's interesting, don't you think? And it's not just true for term 2, it would be true for any term. It would be the average between the term before it and the term after it. Because in here, we use term 2 and term 1, but these could have been this can be true for any 3 consecutive terms. That the middle term of the 2, that term, if I use terms 7, 8, and 9, I could have just replaced 8 here, 7 here, 9 here, and I would have gotten the same result. In other words, every term is the average of the terms before and after it. That's an interesting result. What it also means is that term 2 is halfway between 1 and 3. Do you get that? Which means a lot of things. It could mean that, so for example, what will I get if I take term 10 and I add term 5 and I divided that, or let's say term, is it 1 and 3, 10 and 5. Okay, so let's go, for example, one more. Let's take term 1 and we add term 5 and we divide it by 2. What will I get? Term 3. Because 1 plus 5, 6 divided by 2 is 3. Okay? So in other words, I can literally almost get any term in the middle by just taking the terms on either side. So if I take any term where the footnotes add up to an even number, so I can divide them. So for example, term 30, yes.
Is this, I don't know, you know when you give us like an equation and then there's an x and you like have to find the x?
You could use this.
Okay.
You could use this because this is a property that you can use.
Does it only work with arithmetic?
In this case, yeah.
Okay.
Geometric will work a little bit different. We'll look at that one. Okay, so we'll look at that one and maybe also just find, so literally what I'm doing is I'm just discovering something. It's not, I've never even thought of it like this. Like I'm just playing around with what we are given here, you see, and with that we can do a lot of things and we can discover a lot of properties. So okay, the next important thing is just to say that this common difference, the difference is D, so this is the common difference D. Okay, this expression. So since they equal for any, D can literally be any term minus the term before it. Now if I talk about the term before it, it's 1 less than whatever n is, n minus 1. Okay, that's important. Now if we consider if term 1 is equal to A, so A doesn't have a formula, we just say A is the first term. Then the next term, term 2, is equal to A and then plus D, because the difference between them must be D. So the next term must be 1 D is added, so that now if I subtract these two, A will minus A and I will be left with D. You see that's the difference. Term 3 will be what? It will be A plus D, that one, plus another D. So that's plus 2 Ds. So term 4 will be A plus, or this expression, plus another D. So now it will be A plus 3 Ds. So can you see where we get that Tn, the last term or any term, the general term, is the first term plus, and now look here, when we had 3 as the footnote, we had 2 Ds. When we had 2 as the footnote, we had 1 D. When we had 4 as the footnote, we had 3 Ds. So that is how many Ds will we have is if n is the footnote? Sorry? So what? Yeah?
ND.
No. Because if it's ND, then T4 must be equal to A plus 4D.
N minus.
What? N minus? Don't just guess, guys. Just have a look here. What do you see? What do you see? What's the relationship between the footnote and the coefficient of D? How many D's do we have here? So one less. Perfect. So if this is N, how many footnotes, how many D's will we have?
N minus 1.
Exactly. N minus 1 D. You see, just one less than is already there. How do we do one less? Well, we subtract 1. Okay, does that make sense?
Yes.
Okay, can you see why I don't give formulas in my tests? Because it's not necessary. You must understand what arithmetic series is, and then you won't have to go and remember the
For the
formula.
prelim, do we have a formula sheet?
I'll probably want to not give you one.
But we'll get one, right?
I'm not promising anything.
So
If this,
come
I don't
on,
care. I don't care. I tell you, I have less problems with formulas when I don't give a formula sheet than when I do give a formula sheet. So I prefer not, because students do better without a formula sheet. I promise you that. I promise you that. Okay. What else can you say about the arithmetic series? What else can I, or sequence? What can I think of? Okay. So, so if I know, whenever they talk about terms, whether they're talking about the series, the terms of the series, so they ask how many terms are in a series, we don't use the series formula. We use the term formula. These are the terms. The terms is the T formula. So this is the formula for the terms, a certain number of terms. Now let's look at the series. So the series is exactly the same. It's got the same properties. The arithmetic series has got all the same properties. The only difference is that a series is literally taking these values and adding them together. So for example, S1 is equal to what?
We're taking all of the terms.
So okay, let me say Sn means T1 plus T2 plus T3 all the way up to Tn. So what is S1? So Sn means I sum all the terms up to n, whatever n is. If n is 10, I will say T1 plus T2 plus T3 all the way up to T10. So what is S1? S1 is T1. What is S2? No.
T1 and
T1 plus T2. What is S3?
T1 plus T2 plus T3.
Excellent. Okay, you get it? Great. So now let's go find a formula for Sn. So I'm going to show you the proof. You must know this proof. Okay. So if Sn is equal to T1 plus T2 plus T3 up to Tn, okay, what would be the term right before Tn?
T is an n minus 1.
Excellent. Just the term before it. Perfect. Okay. Now let's just make it easy for ourselves. Let's say T1 is equal to A and Tn is equal to L. L for the last term. Now we already know that the last term is A plus n minus 1d. We know that, isn't it? Okay, because that's what Tn is, but we'll not use that for now. Okay, so now if I now rewrite this, my first term is what? This one will be replaced with what? A. The next term will be replaced with what? I never said that. That would be a lie. Term 2 would be A plus D, just one D, because these two, this one must just have one D extra. Okay, this term will be A plus 2D. Okay, now there's a bunch of terms. I don't even know how many is in between there, but let's now go to the second, or let's go to the very last term. We said that one will be L. What will be the term right before it? What will be the term after it? L plus D. Because remember, the next term must have one extra D. Every time the next term has one extra D. Okay, so but we don't have that many terms. What will be the one before it?
L minus D.
Excellent. L minus D. So that would be my term before it. Now all you do is you rewrite the whole thing. You say, okay, well, let's take this whole thing, but we write it in reverse. So we'll start with this one. L plus L minus D plus, so this is the trick step. It's not really tricky. So what would be the one right before this one?
L minus 2D.
So this one will be L minus 2D plus all the way. Now remember, I'm writing in reverse, so this last term will come there. This, or the first term, the second term will be the second last term, A plus D, and then there's now parts I didn't write, so let's just ignore that part. Okay, now all you do is you say this is equation 1, that's equation 2, and we're just going to add them together. So this is now Sn, and Sn will give me 2 Sn's. A plus L will give me A plus L. What will A plus D plus L minus D give me? A plus L. What will this one simplify to? A plus L. What do you think all of these terms in the middle is going to be? What is this one? A plus L. What is the last term? A plus L. How many A plus L's are there in total? Sorry? So let me ask you in the beginning, how many terms was there in this expression? N terms. That's what the N means. N terms. How many terms were there here? N terms. So if I add them together, how many of these little brackets will I have? No, because you say here's N and there's N, so they grouped 2. These two are grouped together. So yes, there would be N of the A's and N of the L's, but
it's 2 in front.
No, you guys are missing what I'm saying. Look here. There's N terms of these, isn't it? There's N terms here. There's N terms there. Now I group these two together. How many little groups will there be? N of them. Now each one of those little groups simplifies to A plus L. So how many little brackets will there be? There would be N little brackets. Now if I count all of them, there would be 1, 2, 3, 4, 5, 6. There would be 2N terms, but they grouped to 2. So there's N of these brackets. You get it? Are you sure?
Yes.
So I can simplify it. I can say there's N A plus L's. So now this is 2Sn. So now I can just divide both sides with a 2. So this becomes N over 2 A plus L. You see that?
Yes.
Okay. And now again, let's just rewrite it a little bit. Look at this. A plus L divided by 2. What is this? That's the average. So we just take the average between the first and the last term and multiply it with the number of terms. I'm just rewriting this expression. That's exactly the same expression. Just write it in front there. Okay, so that's another way of looking at it. But just to go back so that we have our complete formula, L was equal to what? Good, so we now just simplify. There's now 2 A's. So this is N over 2, 2A plus N minus 1, D. Do you guys think this is a difficult proof? It's just this one little step that's tricky. You see that one? So if you know how to, and you didn't have to use L, you could have used this expression the whole time, but it makes it a bit more complicated because then this term, instead of being A plus N minus 1, it becomes A plus N minus 2D. And the one before it will be A minus N plus 3D. But then there would just not be this substitution step in the end. Okay. So it's really not a difficult proof. Know this proof, it's very important. But what does this represent? Give me in words, tell me, what does this represent? This formula.
Arithmetic series.
Yes, but that's okay, that's words, but what is the arithmetic series?
Isn't it the number of terms in a series?
No, that's what n represents. N is the number of terms in a series.
The total sum is the total.
The sum of the first n terms. Does that make sense? Okay, so let's now look at some type of questions. So often they would give you then just terms like this, terms like this. We'll look at some examples. So I'm not going to no, not like that. They give you this. Okay, so now I'm saying T1, T2, T3, but they're going to give you values, and then they give you a final value. Okay, and then they ask you to find the sum of these terms. Now n, this is going to be a number like 234 or something like that. Okay, so now you have to get the sum. Now notice that in your sum formula, they're asking now for the total sum here. In your sum formula, you have two formulas that you can use. Now remember, it's all about finding the correct equation. So you can either use this one or you can use that one. Now if you want to use this second one, what do you need? This one I'm writing now, what do you need to use this one? You need the constant difference, which is easy to get because they give you two terms. Okay, what else do you need?
First term.
First term, okay, which is easy to get. There it is. You also need n. How many terms are there? Now, if they just give me something like this, I don't know how many terms are there. So I can't just use this formula straight off. I first need to find how many terms are there. How can I find out how many terms are there? Tn is equal to a plus n minus 1 d. Why? Because we have Tn, we have a, and we have d, so we can now go find n. Once I have n, I can use the n that I now have to substitute in there. Okay, so that's a typical way of them asking this type of question. And now, yeah, you know.
Seeing that if you use that one, you're gonna do a lot more work than you would do this side.
Even this side, look, I've got the last term.
But you still have n.
Sorry, I still need n, so yes. So there's no way around it. You'll have to use, first find out how many terms are there. Okay. Is there a different way? Let's see. It's the average between how many terms are there and, well, let's see if we solve n here. Let's see if there's an easier way. N minus 1 is taking the last term, so this is now the last term, minus the first term divided by the constant difference. So n is the last term minus the first term divided by the constant difference divided minus 1 plus 1. Could do that if you want to remember this formula. Taking the difference between the last and the first term, dividing by d. So if I take the difference between the last term and the first term and I divide by d, I'm literally calculating how many times did I add d. That's literally what I'm working out here. How many times did I add d to the first term? And then I must add 1 because my first term didn't have a d added. So I'll add 1. So this is maybe how you can understand that formula. But again, it's easier way, well, simpler way without going to try and remember that. Okay, another way that they might ask you is that they give you Sn is equal to, oh no, they give you the sum, something like this. They say T1 plus T2 plus T3 up to, and then this time they don't give you Tn. They don't, you just know that there's a last term and they say it's equal to, and now they give you, this term is known, like they say it's 506 or something. So you know what the sum is. You're not asked to find the sum, you're asked to find n, the number of terms. So you have this and this and this, and you have to find the number of terms this time. So we can't use this formula because we don't have this Tn value. Okay, but we have Sn. So which formula would we use? We'll use this formula. Okay, and now let's see in that formula, Sn is equal to n over 2, 2a plus n minus 1d. What do we have in this formula? Do we have Sn?
Yes.
Yes, so we've got Sn. Do we have n? No, this is the one we're trying to get. Do we have a?
Yes.
Yes, they're going to give me that term. Do we have n? No, so n is still unknown. Do we have d?
Yes.
Yes, easy to get. I still have to calculate it, but that's just the difference between those two. Okay, so now I just want to show you something. Notice the values that we don't have is n. And in n, this is going to multiply n. Do you notice? So this is going to simplify to a quadratic equation. So now, if I multiply n, let's quickly multiply n and then you'll see. So if I multiply n over 2 with that, then I get na, let me actually write it as an plus, and this one, if I multiply this one in, I get dn times this n over 2, so it's d over 2n squared, and then minus d over 2 times n. So I'm just going to rewrite this a little bit. So I get d over 2n squared plus, and now I'm going to take out an n as it, because n is what I'm trying to solve. It's my unknown. This one is plus a minus d over 2 times n. So in our quadratic equation, okay.
So why isn't it 2an? First thing.
Because the 2's cancel.
Oh.
Yeah.
Right.
Okay. And then on this side we still have an Sn. So if I on this side I've got an Sn. I actually want to take this Sn to the other side so that this is 0. So here I've got minus Sn. So notice here's my A, B, and C. You see my quadratic equation. How many answers am I going to get? Sorry? 2 answers. And one of the answers is going to be nonsense. What do I mean by nonsense? I mean it makes no sense. In other words, one of the answers is either going to be a fraction or it's going to be negative. You understand what I mean? So why is a fraction or a negative answer nonsense?
Yeah. 1 comma something 80 terms.
Yeah, so it's because n is a counting number. It is a number you must be able to count, and you can't count fractions and you can't count negative. Okay, does that make sense?
Yes.
So in other words, we won't say, we use the word not applicable, meaning yes, it's an answer to this equation, but it's not applicable to this situation. Make sense? Okay, so we don't say no solution. No solution means something else. It's not applicable. Okay, that's another way they might ask it, and I've not looked at sum notation, but let me just quickly look at sum notation for the rest of this. So sum notation is really, really simple, guys. All it is that I have this little variable here at the bottom of the sum notation that changes values. It starts at whatever you give it a starting value. So I'm going to just start at 1 and go to n, and then I'm going to say ti. Now it simply means sum, and then I'm going to start with I equal to 1, and then this is t1 plus. Now I go to the next term. I is now 2, so t2. I is now 3, so t3. Plus all the way up until I is equal to n. Now I and n might be known numbers. I would usually just be 1, but it could be something else, and n could only be either n or a fixed number, okay? But the last term when my I value reaches this top term, that's when I'll stop. Now I won't add anymore. Okay, so an example, if I'm working with arithmetic series, then my term in here will have an arithmetic format. For example, it would be a plus I minus 1 times d. So I is equal to 1 up to n. Now look what happens. If I is equal to 1, what do I get? Do you see this is the general term? It's the same as the general, there's just an I, and I now starts at 1 and ends at n. So my first term would be what? I minus, so I is 1, 1 minus 1 is 0, times d is 0, so I'm just left with a, that's my first term. What's my second term? I is equal to 2. 2 minus 1, 1 times d is d, a plus d. What is my next term? You see, it's just a short way. The next one will just be 2 because I is now 3, minus 1 is 2, so it's just a plus 2d. So it's just a shorthand way of writing all this. Do you see? So now if they ask me to write a certain series, they give me a series. Now again, term 1, term 2, terms 3, all of these terms are given, and term n is given. And they ask me to write it in sigma notation, then it's easy. I just know, well, this is an arithmetic series, so I must write a plus I minus 1d. I will start at 1, and I need to know the following. I need to know the first term, the constant difference. I remains I, because he just gets values from the sigma notation. But I need to know n. How will can I find a?
Yes.
Easy, there's a. Can I find d?
Yes.
Simple, just that. Can I find n?
Yes.
How?
I'm just gonna.
So this will be a number like 234.
Yeah, so you're gonna use your arithmetic equation T.
Yeah. So you're just going to use this formula in the same way that we tried to find n here. That we tried to find n for that one. We're just going to use this formula. We've got a, we've got d, we've got tn, the last term, and we just now find n. So again, this question, for example, will be 4 marks. And this question, for example, will be 4 marks to write an expression in sigma notation because of the work needed to be done to do that. Okay, so it's really not difficult. It's not a complex thing. Okay, now one more thing, actually 2 more things. So they might now give you something like this. They give you now an expression like this, and this might be simplified, remember, so it doesn't have to be, the point just being that so let me not write it like this, let me write it as a, not even a, mi plus c. Okay, an arithmetic equation, the general term, that's a general term, will simplify to look like a linear equation. So for even this one, tn is equal to a plus n minus 1d. Look how it simplifies to look like a linear graph. I multiply n and then I get dn plus a minus d. And see how I got there? I've got the d times n is my dn, and the a, and then the minus d comes from there. You see that? Now why do I say this is linear? This is like mx plus c, where my x is the value that changes, the m is the gradient of the line. The gradient tells me how much do I change for every step, and that's exactly what d is. For every one change in n, my numbers change with d. And c is my y-intercept. Okay? In other words, it's when n is equal to 0. But our n is never 0. We don't have a 0 term. But what is, we have term 1, term 2. What is term 1? A. What is term 2?
A plus C.
If I had a term 0, if it was possible to have a term 0, what would term 0 be? A minus 1D. Do you see? It is a straight line. D is my gradient. It tells me how much do I change with every one step. And C, that part of it is my gradient. So in other words, this is really, if I simplify it, the format that my arithmetic series will have in a sigma notation. So they maybe give me something like this is equal to Sn. That's exactly what it is. You get it? Now they might give you different values. So before they wrote it like this. Where did I do that one? Here. Okay. This is just a different way of writing T1 plus T2 plus T3 up to Tn equals to Sn. And in this they can now leave out any value and ask you to find any other value. But it will work exactly the same as this. Okay, so we're going to do examples like this. The final one I want to show you now is that they might start by giving you Sn as a formula. Okay, so notice Sn as a formula. Sn as a formula would look like this. Where did I simplify it? Yeah. They give you Sn as a formula. It would be a quadratic formula, but n is unknown. They just tell you the sum is given by Sn, and now it's some sort of expression an squared plus bn. Okay, you'll see here, there's all the terms on the side have an n, and there's not an extra term. So they give you this formula. And now they ask you, find term 10. Something like that. Is term 10 equal to S10? No. So how would we, so for term 10, what do we need?
We need
Plus, but it's 10. So it's 10 minus 1. So 9 D's. So what do we need to find term 10? We need the first term. Now, this A is not the same. They're not the same A's. Okay. So let me just call this not A. let's call this blue A. Although that's blue A and blue B. Okay. So they don't have anything to do with this A and D. Okay. So I need the first term, and what do I need? I need the constant difference. Now, how can I use my sum to get my first term and my constant difference?
I'm just going to try and solve, because we have Sn, right?
Yeah.
But we don't have A. We have A.
Now, this is a general formula. So in other words, you can now ask me, what's the sum of the first 10 terms? And I just put 10 in here, and I can tell you how much, what is the value when I add up the first 10 terms.
Okay. So why don't we calculate the sum to 10 terms? And from there we could calculate, we could say, because we know what S10 is.
Yeah. You can get any S, but you can get S10, yes.
You're only given SA. There's no A.
No, you have these values. They're real values. I just don't want to give an example at this point. Yeah. So you have these values. So in other words, for example, if you put in 10 here, you'll get an answer like 47. Or do you understand what I mean?
Yeah, but if we get an answer, that means we get A, right? Because when we say, okay, since we have SA, we don't have A, that's what we're looking for.
No, we're not looking for n. We're looking for term 10. They're asking for term 10. We know what n is, we want the 10th term. So we either need to use this formula where we need the first term and the constant difference. So how can I use the only thing they've given me is the sum formula. How can I use the sum formula to get the first term?
The first term is given.
Where's the first term?
It's not. Why don't you calculate the sum to 10 terms now?
Yeah.
And then from there, because S9 is equal to S10.
Wait, you say S9 is equal to S10.
Shouldn't you say the sum to any term is equal?
No.
So you have misunderstood.
No, so this is S10 is term 1 plus term 2 plus term 3 up to term 10. S9 is term 1 plus term 2 plus term 3 up to term 9.
If we know what S10 is,
We know we can substitute 10 in here and we can get
You put
S10.
9 also.
Sorry? And
You
okay.
put the 9 and 8. How to do that?
We could do that. You're going too far, yeah?
can't we, because we have S10, right?
Yes, we've got
So that means
S10.
we have, can't we use T9 and then do that whole thing you did?
This side. Yeah, sorry. Can you guys see there? Shouldn't you, Lou? Okay. Exactly what I did before, isn't it? You're right. You're on the right track. So in other words, what's the difference between these two terms? Does this one have all the terms up to 9?
Yes.
But he's got one extra term.
So then,
So I can just subtract the two terms, isn't it? Do you understand? So in other words, if I have the sum to the first 10 terms, and I have the sum to the first 9 terms, then the difference between, so in other words, S10 minus S9 is equal to what? What's the difference between S10 and A9? Just hear the sentence. S9 is the sum of the first 9 terms. S10 is the sum of the first 10 terms. What's the difference between the two? Not 1. It's not T1. Both of them have T1 in it. Listen to my sentence. Term S10 is the sum for the first 10 terms.
So you need to twice 8, isn't it?
Listen to my sentence.
difference is the sum.
Is the sum good? But what makes that they get different answers? Why do I get different answers for S10 and S9?
Because S10 has what term?
Which term does it have? It has term 10. What is the difference between S10 and S9? Term 10. Does it make sense? Can you hear? S9 is terms 1 to 9. S10 is terms 1 to 10. So S10 has all the terms of S9 plus term 10. So that's why the difference between S10 and S9 is term 10. Look at this. If I subtract these two sides, S10 minus S9, term 1 will give me 0. Term 2 minus term 2 will give me 0. Term 3 minus term 3 will give me 0. This will go all the way up to term 9. All of them will give me 0, and then there would be term 10 and would be nothing to subtract from it. So I'll get term 10. Does that make sense?
Yes.
Now, okay, so let's look at another way. How could I have maybe used this formula? Well, it's still easy because what is S1? T1, which is A. So I've got A. All I do is I put an N in here. I put 1 in there and I get term 1. Now what is S2? T1 plus T2. How can I get S2? I just put a 2 in there. And so if I put a 2 in there, I get the sum of these two terms. I don't get, so now I get S2, okay? I don't want S2, I want T2. But I got S2 from the formula. I've got term 1, so term 2 is the sum of term of S2 minus S1. But S1 is also T1, which I already calculated here. You see that? But let's keep it S1. And now I got term 2. How will I get D now? Yeah, D2 minus T1. You get it? So here's something important to know, that any term is equal to the sum of all the terms minus the sum of all the terms before it. So remember, Sn is, so for example, S10 is the sum of the first 10 terms. So that's the same as saying the sum of the first 9 terms plus term 10. Do you agree with me? Are you okay with that, Olivia?
Yes.
Okay, so in other words, Sn is the sum of all the terms before the last term plus the last term. In other words, that's where I get this formula from. Look how I'm going now. All I do is I subtract this on the other side, and I get that formula. Do you understand? Okay, so keep that in mind. That's very useful. Okay, and so let's with this go and look at some questions from that assignment. Okay, so here we have a few questions. Okay, the 48th term of an arithmetic sequence is that, and the 80th term is that. Calculate the first 2 terms of the sequence. Okay, so this question most people got right. It's not very difficult. We had a lot of them practiced in the question paper as well. So they say the 48th term of the arithmetic sequence. So T48 is equal to negative 328. And the next one is, the 80th term is, so T80 is equal to negative 552. Okay, give me some suggestions. Okay, it's not bad. T80 minus T48. Okay, let's see what we get. So negative 552 minus minus becomes plus 328. Okay, and how will that work? What can you do on this side?
Can't you expand it?
Yeah. And so what will T80 be?
Equals to A plus 8 minus 1 T, and then minus A plus
47D. Just notice something I always do. When I subtract something and I replace that thing that I subtract, I always put it in brackets. Even here I did it, but I did it in my head. So this was minus 328. Okay, I just did that. So please keep that in mind. So that is, what do we get on this side? 320 is 224. I think so. Just check me, please. Test me. Okay, and now what was very nice about doing this is notice that when we subtract, we are dividing. We're subtracting the A's. the first terms. Doesn't become an issue anymore. So when I subtract it, I get 79 minus 47. So 79 minus 47 is 32. 32 D's is equal to negative 224. And so now we can just divide 32 on both sides. 32 divides in there 7 or 8 times, 7 times. So D is 7. Negative 7. Oh yes, of course. Okay, how will we get A?
We can substitute D in any of the two formats.
Exactly. Okay, so we could say, okay, T80 used to actually be, oh, let's, 80 is fine. A plus 79 times negative 7 should now give me negative 552. So A would equal 7 times that, 560. So negative 552 minus plus 553. So is A equal to 1? Did you test this? 79 times negative 7? You sure? So A is equal to negative 1. So they tell me T, so we know Tn is equal to 1 plus n minus 1 times negative 7. So they asked me for the first two terms, calculate the first two terms. So I know term 1 is equal to 1 and term 2 is equal to yes. Okay, I want to show you something cool here that I've also not thought about. But let's say they give me two terms, term n and term m. Two different terms, n and m, we don't know how that. So this one is a plus n minus 1d, and this one is also a plus but m minus 1d. Now look what happens when I subtract them from each other is tn minus tm, a minus a gives me 0, m minus, so I get n minus n d minus m minus 1d. And now I take a d8 out as a common factor, so I get n minus 1 minus m plus 1d. You see where I get the minus m plus 1 from? Okay, so this simplifies to n minus m times d, and now so d is equal to tn minus tm divided by n minus m. Does this look familiar to you? Just slightly familiar, doesn't it? Just give you a slight, come on man, somewhere. I'll tell you what, this is the change in t divided by the change in n. Come on, now it must look a little bit familiar. I'll give you more clues. If I take Tn, remember, I could rewrite it. I showed you earlier that A is a linear n, d times n plus a minus d. What is, and this had the form of the straight line. Y is equal to mx plus c. So what is this?
What's okay?
D is the gradient. How do we calculate gradient? change in y divided by change in x, and in this case n represents x. So this is an easy thing you can try and get. If you wanted to get d, they give you any two terms. You can just say, well, let's take the difference between those two terms, the value of the terms, divided by the difference in the term numbers. And that's exactly what we had here. Let's see if we can quickly do it. The difference in the terms was negative 553 minus plus 3, what was it? 328. 328, that was the difference in the y values or the t values divided by the difference in their term numbers, which was the one was 80 and the other one was 48. 48. See what you get? -7, isn't that cool?
See your interesting method for the prelims and the finals. Can I use that for maths to get it right?
Yes.
So with maths, you know when you guys go and walk somewhere.
Yeah.
The president.
So they do.
Well, I can tell you one thing. The markers for Sakai they're amazing. They don't just mark according to the memo. While if you do DBE papers, you don't know who's marking your papers there. I must be honest. I don't know. I can't say anything about them, but you don't know. They've got thousands of people marking. Where do they get all these thousands of math teachers? They don't exist. Sakai doesn't. I think Sakai has about 5 people marking, and they're all very proper, very intelligent,
Not very
good.
leniently.
Not leniently, very strict. But they would, if you use a different method, they will make sure they check your method. And if you use something that's valid, they will give you the valid marks. Okay. But this is quite cool. I think it is. D, and obviously we'll get a just again by substituting into one of those formulas, even if we use this cool formula for D. Let's go see if there's another thing we can do with arithmetic or geometric. The sum of an arithmetic series is given by find the constant difference between the terms. Okay, how about you guys try that? Okay, so let me quickly look at that. So they give us our Sn. Our Sn was what, negative 10n squared plus 28n. Is that it? Okay. So in other words, S1 is equal to term 1 plus nothing, because I'm adding the first term, which is equal to a 1 in here. That gives me negative 10 plus 28 is negative 18. S2 is equal to term 1 plus term 2 is equal to, and now I know what term 1 is. It's already negative 18, so plus term 2, but this must equal, I substituted 2 in there. 2 squared is 4. 4 times 10 is 40, so negative 40 plus 28 times 2. What? Oh, sorry. Yeah, sorry. Okay, so 28 times 2 is 56 minus 40, that's 16. No.
Yes.
Positive 16.
Yes.
Cool. So if term 1 was 18, and I add term 2 and I get 16, it means term 2 was negative 2. So I've got term 1, term 2, that means my constant difference is term 2 minus term 1 is equal to negative, it's equal to 18 minus 2. No, sorry, I'm doing it wrong way around. Term 2 is minus 2, minus term 1 is 18, so my constant difference is negative 20. So I should have actually started by looking what they're asking for. They're asking for D. What formula do I have for D? Well, we've got that cool formula of ours. You could have used it. Yeah, but it's the difference is what's change in N. I'm using term 2 and term 1, so what's the change in N? It's just 1. what is the change in t? That's term 2 minus term 1. So you can just maybe remember this formula because it encompasses all possibilities. So, but then term 2 is negative 2, term 1 is negative 18. So I have term 2 minus term 1, that's this change in n, but that would also give you negative 20. Okay, let's see if there's another question, arithmetic series. Oh, here we go. How do you know whether this is geometric or arithmetic? I know we haven't discussed geometric yet, but just by looking at this, based on what I've said,
you substitute t.
Okay, that's one way. That's one way. You can substitute t, but there's an easier way. I mentioned it now before. By just looking at it.
A linear thingy.
It's a linear expression. If I put my unknown, that t, if I replace it with an x, then it's mx plus c. You see? Then you know it is arithmetic. So in other words, and what does this sigma mean? It means sum of. So what formula am I going to be using? So I'm going to be using Sn, and they tell me my Sn is equal to negative 217, and I know my Sn, because it's arithmetic, is n over 2a plus n minus 1 d must equal negative 217. So now they ask me to find n. They say find n, which means in this equation, what do I need? I need my first term. How will I get my first term? Substitute whatever this is. In this case, it's 1. If this was 7, that's what I would substitute. Okay. So, but if I do 1 in here, I get negative 3 plus 7, which is 4. So my first term is 4 n over 2. 2 times 4 plus n minus 1. N is what I'm trying to find. My constant difference. How will I find my constant difference? Substitute 2. Okay, so if I put in a 2, I get negative 6 plus 7. So I should have actually just maybe substituted terms like you would have in the beginning to see it's arithmetic. Then I'd get my first term is 4, my second plus, because it's plus, my second term I would find as negative 6 plus 7, which is 1. My next term, when I put it in, is 3, so it's negative 3 plus 7, sorry, negative 9 plus 7 is negative 2. Okay, and now I can find my constant difference. What's the constant difference?
1 minus is negative 3.
Yeah, negative 3. Guys, but I wanted to show you here. Look at that. Remember when I said in the linear, it's your gradient.
Oh my goodness, so you were so good.
Oh, it's not me, it's maths that's so cool. So do you see in here, once you recognize that this is a linear expression, then literally what that negative 3 is it's your constant difference. Because each time I add a t, a different t, I'm adding that negative 3 again. You see? And then the 7 is a minus d. So if I add my common difference again, so 7 plus d would then just be my first term. Okay, but the first term was easy to find. Okay, so anyway, so here we get our d is negative 3 is equal to negative 217, and now I must just simplify. So I multiply in. What I like to do is I just like to multiply the 2 on the other side so that I can get rid of this divided by 2. So I multiply only an n in here, and the 2 I multiply on the other side. So I get 2 times 4 is 8n plus this negative 3 makes it negative 3n squared. And then the negative 3 times that 1 gives me positive 3. So plus 3n is equal, and then I just double the other side, which is negative 434. And now I just write it as 3n squared minus 11n minus 430. I'll show you now. Because it's 3n squared with a negative. So they're supposed to be negative, positive, positive. You see, so negative 3n squared plus 11 plus 433, but I don't want that negative in front. So I just changed all the signs. I just skip a step in my head.
Don't do that.
I would recommend that you write out all your steps, but then I would start recommending that you stop writing out all your steps. And the reason why is so that your mind can, because what you guys do is just use your calculator. You just switch off your mind anyway. So just use your mind. It will improve it, I promise. Okay, now to do this, I just use the the quadratic formula. I don't even try and find the factors. It's just easier with the formula. What is it? Over 3. Excellent. So in other words, can you see how this one is nonsense? So you could write nonsense or no sense. It wouldn't be wrong. Nonsense or just not applicable. Nonsense. Now what does nonsense mean? It means no sense. So if you are speaking if you are speaking nonsense, it just means you are making no sense. So it's rude. It's rude unless it's true. Okay, so there we go. There's 14 terms in this expression so that it sums up to negative 217.
Maths
is quadratic. A combination of an arithmetic and geometric. We'll do that one now. Okay, cool. Let's go on. Let's take a break.